matter experts. PhilSihub Research University will be your personal coach through every stage of your research project, from ideation to final assessment.
And the best part, it's absolutely free.
Visit us at philsihub.com and be part of this learning journey.
Let's learn and succeed together here at PhilSihub Research University.
Mabuhay! Welcome to the Filipino Science Hub. Thank you for your continued support to this online platform. To our new participants, thank you for checking us out today, and we would like to Hub. Before we start the webinar, I would like to share some house rules in order to facilitate a smooth session. For our Zoom participants, we would appreciate it if you could turn your audio and video cameras off during the webinar. If you have questions or comments, feel free to type them on our Zoom chat box or YouTube live comments, and we will try to accommodate as much questions as possible. After the talk, we will have a 30-minute Q&A where the Zoom participants will have the opportunity to ask their questions live. For those who would like to receive a certificate of participation, a Google form link will be posted on our Zoom chat box, YouTube live comments, and YouTube video description towards the end of the webinar. Again, welcome to all our Zoom participants and YouTube live viewers. For those who are new and may not be familiar with who we are and what we do, allow me to share our mission and vision in the next few minutes. Filipino Science Hub is an online platform founded by our CEO, Filipino scientist, Dr. Jeffrey Camacho-Bonquin back in 2012. Currently, we are a registered nonprofit organization based in Houston, Texas, United States. Our mission is to promote STEM education and the culture of research among students and teachers in the Philippines and abroad. Our current global leadership team is comprised of volunteer Filipino scientists, seasoned STEM educators, and business executives across the globe. Our vision is to see a technology and innovation-driven Philippines, and we believe that this can be achieved by creating a new generation of well-rounded Filipino STEM enthusiasts. The vision is being carried out via our two major programs, the PhilSihub Ed program and the PhilSihub Research University. Through PhilSihub Ed, we are able to empower and support our teachers by strengthening STEM fundamentals education. We believe that this is important because the more equipped our STEM educators are, the more they can inspire students to pursue a career in science, technology, engineering, and mathematics. The other major program that drives our vision forward is PhilSihub Research University. This is where we provide tools for fundamentals of research and closer to the educational sector. Our official website is www.philsihub.com. This is where you can access all our materials such as webinars, tutorials, modules, virtual lab, and features, all of which are free. We are also present in several social media platforms, so follow us wherever you are most active on to get updated with our web events. Again, thank you for being with us this morning. To officially start our webinar, I would like to turn the virtual floor over to our host today.
All right, good morning, everyone, and welcome to the DIY Physics Experiment webinar hosted by the Physics Division of the Institute of Mathematical Sciences and Physics of UPLB in collaboration with the Filipino Science Hub or PhilSihub. And on behalf of the organizing committee, I would like to express our deepest appreciation to our dear participants, the students, faculty members, and our other working professionals for allotting time to be with us today here in Zoom and on YouTube. Yes, we're live on YouTube. And yes, to formally start our event, let's hear a message from Dr. Editha C. Jose, the Director of the Institute of Mathematical Sciences and Physics, for the welcoming remarks.
On behalf of the Institute of Mathematical Sciences and Physics, UP Banos, I would like to welcome you all to this series of webinars to celebrate October as the Physics Month. I am thankful to the whole organization of the Filipino Science Hub headed by my former student, Mr. Jeffrey Bongkuin, for collaborating with us in our common pursuit to uplift the quality of STEM education and research in the country, and at the same time, to promote the wonders and power of mathematics and physics. Our institute, the IMSP, is enthusiastic with regard to the co-staging of this highly anticipated activity, which is indeed timely and helpful for physics teachers, researchers, and enthusiasts like me. I am also proud of my colleagues who agreed to give their time and effort to enlighten all of us, especially that physics is one of the fields which is deemed to be difficult. But you will agree with me that it is really fascinating. Last week, the NASA spaceship struck an asteroid 7 million miles away in order to deflect its orbit, succeeding in historic key test of planetary defense. I have watched the movie Armageddon several times, being a fan of Bruce Willis. Last week's feat where the double asteroid redirection test or DART impactor hit its target, the space rock Dimorphos. It reminded me that Bruce Willis need not to die to save the Earth. At the IMSP level, you must have heard of the BS Applied Physics student, our very own, William Kevin Abran, who took a step forward for Filipino physicists to have his experimental proposal conducted in the International Space Station. We are very proud of him. For the second offering of this month-long celebration, we will feature some DIY experiments prepared by our physics faculty members who will present innovative and creative setups in teaching physics. So let's learn while enjoying today's video presentations. And it will not end here. We have quantum and computational physics talks towards the middle and end of the month. I truly appreciate and thank our speakers for this Physics Month. To all our participants, either in Zoom or YouTube, thank you for your participation and we hope to see you every Saturday. This is just the beginning of PhilSihub cross IMSP collabs, so watch out for more.
All right, thank you very much, Dr. Jose, for that warm welcome. I believe she is also here with us in the Zoom meeting. So thank you very much, Ma'am Edith. And I know that we are all excited to learn and to ask questions to our presenters. And I hope that we listen attentively because there will be a pop quiz later on as we go on with the program. And now to introduce and give a short background on the experiments that we will be performing, let us watch a video by Dr. Rhea Mero, an assistant professor of physics at the IMSP.
Welcome to the DIY Physics Experiments. In this seminar workshop, we will be introducing DIY science activities. A laboratory activity is an integral part of learning science concepts. These activities play a critical role in the students' active participation in the learning process. It has been known that when students are actively engaged in learning, doing the actual observations, performing experiments, working collaboratively with peers, manipulating actual variables and conditions, making graphs and tables, learners easily grasp the concept in a deeper level and are able to interpret results in a meaningful manner. In addition, this learning is retained for a longer period. In a way, having a laboratory activity is a good method that helps connect theory into practical applications and develop critical thinking and problem-solving skills among students. With the onset of the pandemic, educators have moved into the virtual mode of instruction, and creating remote laboratory activity for students have become a challenge. Most have resorted to the ready-made datasets, which lacks the essence of a laboratory activity. However, most people nowadays have smartphones, tablets, and other mobile devices. These devices are proven to be powerful educational tools. It is important that educators learn to tap into these resources in designing laboratory activities that are safe, easy to set up, and can be done both at home and at school with minimal supervision. With the technology becoming more and more advanced, our smartphones are now equipped with sensors capable of quantifying several data. These sensors, such as the proximity sensor shown, brings learning outside the laboratory and into your fingertips. Other sensors that makes up a smartphone device are the accelerometer, magnetometer, gyroscope, light sensor, pressure, humidity sensor, microphone, GPS location, and Bluetooth. In this webinar workshop, we will be introducing mobile phone applications such as PhilSihub and Physics Toolbox. These apps allows the use of these sensors in a smartphone to measure, record, and analyze data that are suitable for science laboratory activities. The laboratory activities in the seminar are focused to two topics in physics. The first group of activities are related to mechanics. And the second set of experiments is about the properties of light, such as the inverse square law, reflection, transmission, and absorption. For the mechanics experiment, the PhilSihub mobile phone app will be used, while the physics toolbox will be demonstrated in the light properties activities. These mobile apps can be downloaded free on your smartphones through Google Play for Android users or through the App Store for iOS users. Or you can use the following QR codes that could direct you to these apps.
All right. Thank you, Dr. Mero, for that introduction. We have powerful smartphones and applications that can be used for various physics experiments. And so for our first activity, that will be the pendulum experiment with the objective of calculating the acceleration due to gravity. And as Dr. Mero has mentioned in the video, this activity can be done in classes discussing topics in mechanics. I would like to encourage everyone to follow the procedure on the worksheet sent to you while watching the video prepared by Dr. Cheska De Vera and Sir Nelio Altaveros on the pendulum experiment. So later on, they will be here with us to entertain questions. So can we now flash the video on the first experiment?
Hello everyone. This DIY experiment is about simple pendulum and measuring Earth's gravitational acceleration. Possible learning objectives are: set up a simple pendulum experiment using a smartphone and PhilSihub application. Measure the period of a simple pendulum of various lengths and mass. Determine the acceleration due to gravity using a simple pendulum. Materials for this activity are smartphone with PhilSihub application, ruler, tape, string or cord, cardboard or thick plastic, coins, and weighing scale. In this activity, we will use an application called PhilSihub. PhilSihub is a free access software that allows you to use the mobile sensors in your experiment that supports the following inputs. For the pendulum, gyroscope sensor will provide period and frequency oscillation of the pendulum. Setting up the pendulum. Setting up the mobile phone as the pendulum bob may be a little tricky. Here, using mobile phone alone as a bob results in spinning or additional rotation of the pendulum. To eliminate this, we will use a slightly modified version of a simple pendulum as shown. First, make a pouch that can hold mobile phone, and coins using a thick plastic container or cardboard. Step-by-step procedure on making a pouch from cardboard is provided from the teacher's guide manual. You may also let your students design their own pouch to develop resourcefulness and creativity. Tell your students that the pouch should be strong enough to hold the phone and coins, and it should be act to minimize the spinning motion of the pouch bob as it oscillates. Data measurement using VFox. Start the VFox application. You can see different types of sensors and tools you can use. For this activity, select the pendulum experiment in the mechanics category. Results give the average period and frequency of oscillation. G gives acceleration with the given pendulum length. Length gives the pendulum length assuming the theoretical value of G. Here is resonance, autocorrelation, and gyroscope data in X, Y, and Z axis. To gather data, click on the three dots on the top right of the application. Click on Do a Time Graph. Set the start delay to 3 seconds and the experiment duration to 10 seconds. Activate the acoustic signals. You can also access the gyroscope data as shown. To save, click the three dots on the top left and select Export Data, then press OK. The first part of the activity is measuring the period of the pendulum with varying mass. The students may do this by attaching different number of points in the pendulum's bob. The students may analyze their results by plotting the period versus the pendulum's mass. The second part of the activity is measuring the period of the pendulum with varying lengths. The students may analyze their results by plotting the period versus the length of the pendulum. Finally, by plotting the period versus the square root of length, the students may obtain an experimental value of G. Encourage the students to take a picture and video of their setup. You may be surprised by their ingenuity. Thank you for listening.
All right, so that's it for the pendulum experiment. Can we give a virtual hand to Sir Nell and Ma'am Cheska who prepared the video and who performed the experiment? So thank you, Ma'am Cheska and Sir Nell. And I'm sure some of you have questions to ask, but before we proceed to the Q&A, we will be first having a pop quiz. So we will be flashing a question, and the first one to answer the question correctly in the chat box will be the winner. So we know that there are participants watching us via YouTube, but this will only be open for those who are joining us here in Zoom. Okay ba yun? So let us, can we now flash the question? So,
Ella, where's the question?
oh, okay. So
Yeah.
let me just read the question, sir. So the question is, when doing a timed run in VFox, how long is the default setting for start delay or the default time before experimental duration? So when doing a timed run in VFox, how long is the default setting for start delay or the default time before the experimental duration? So I'm seeing a lot of participants answering here in our Zoom chat box. So the correct answer is 3 seconds. Okay, so the first one to type the correct answer is Sir Rosales, Sir Ian Rosales. Can you turn on your camera, Sir Ian? Hello, Sir Ian. So
Hello po. Good morning.
can you give us a quick introduction of yourself? Are you a student or are you a faculty member? And where do you teach or study?
Good morning, everyone. I am currently teaching in Manresa School. As you can see, as my background, no. So I'm a physics teacher. I'm teaching grade 8 and grade 8 to 10 physics.
Right, wow. Yeah, congratulations again, Sir Ian. And someone will message you for your prize. Okay, so you have a prize for getting the correct answer.
Thank you.
Okay. All right, sir. So now let's call on Sir Nel and Ma'am Cheska to entertain questions from the audience.
Hello, good morning, everyone.
Good morning, Ma'am Cheska.
Good morning.
All right. So anyone, do you have questions to ask to Ma'am Cheska and Sir Nel? Okay. Sir Nel or Ma'am Cheska, I would like to ask, are sensors or mobile applications like the ones mentioned by Dr. Rhea in the introduction, the PHIFOX and Physics Toolbox, are they designed to work for a specific experiment as shown in the video, or can we also perform or explore other experimental setups?
Okay, let me answer that question. So I've been using this VFAX experiment, so you can use so many sensors in your smartphone, and of course it will depend on the type of smartphone that you have. But if you have a pretty nice smartphone with several sensors, you can already do experiments. Not only the ones presented here, like the one in the free fall or the one in the one that we're doing, but you can attach this to different devices. For example, to a spring. So if you connect it to the spring, you can look into simple harmonic motion, and you can make use also of the sound, no? So meron siyang parang microphone and then yung speaker. So you can do, for example, measurement of sound, yung sound speed. You can do that like a sonar. Alam niyo yung sonar, yung pag nag-reflect yung sound, you can measure yung distance of the object. So there are other things like meron siyang accelerometer, meron siyang gyroscope. So pwede kang magawa, for example, na ilagay mo siya sa spinning object or material, and then you can measure forces, yung mga angular acceleration, angular velocity, and so on. That can be done. So it depends on yung gusto mong gawin. Kasi
Yes.
the sensors are general, so you can make use of them, no? Marami siya. May GPS, meron siyang sa sound, syempre, sa magnetism pwede rin kasi may magnetometer. So you can do experiments with magnets. And not only in class activities, you can also do this in research. Kasi same instruments are being used in doing research work. As long as you are creative, you are innovative, you can do a lot with this simple smartphone. Yeah, maybe you can have it, let's say, try it, put it in a balloon and let it fly or whatever. But of course, that will be risky. We do that. We can also put it in a boat and let it, say, pass travel waves. And for example, you can do that. But of course, yeah, you have to be creative in that experiments.
Yes, thank you, Sir Nel. We have questions here in the Zoom chat box. So from Alfie Badilla, how accurate is the result using this app?
sino masasagot si Ma'am? I can answer also kasi
You can answer
hindi-
it yourself.
yes,
Sorry, Nel.
yes, okay. So, it depends on the setup, no? Kasi when you're using PFAX, hindi lang naman siya yung yung gagamitin mong instrument. So, you have other components that you have to put in. So, the accuracy will be based on yung proper setup mo, no? That's why meron tayong mga susundin na mga guidelines to be able to maximize yung effect. So, yung error nito siguro 5%, depende, ganyan. So, pwedeng mag 10% kung okay
Yes.
yung gagawin mo.
Apo. But can we calibrate it first before we can use it?
Merong part na pwede i-calibrate, like for example, if you're trying to use yung sa sound, no, yung meron tayong tinatawag dito na yung acoustic stopwatch, for example. In the acoustic stopwatch, you can use clapping to start out stopwatch and end it by clapping. And you can calibrate it because it can pick up yung sa environment noise and that will trigger yung experiment mo. There's a good example of that in free fall, no? Yung gagawin dito is you place a balloon, tie up some weights, and then you burst the balloon so it will produce sound. And then when the body reaches the floor, meron siyang plate, so magpo-produce siya ng sound, and then you can measure acceleration due to gravity already with that very simple activity. Yon, pwede mong gawin siya and then you can calibrate.
Okay, sir. Thank you po. And we have another question here regarding the app itself. So, can PFOX run online, either online or offline, or is it compatible in any Android OS version?
Yes, you can download the PFOX application and then you can perform experiments offline. And then I think available siya for Android 4.0 and OS version. So yung ibang mga cellphone kasi for example yung ibang mga cellphone kulang siya ng sensor, pero I think lahat ng mga Android cellphone may accelerometer. So depende din sa katulad ng sinabi ni Sir Nel kanina, depende din sa cellphone na gagamitin. Yung ibang mga cellphone equipped sila ng maraming sensor. And then yung ibang mga cellphone may ibang sensor na hindi kompleto. Okay? So depende din sa mobile phone. But I think lahat naman ng mga cellphone may accelerometer, so you can do so many activities with an accelerometer sensor.
And also free yung app,
Yes.
no ma'am?
Yes, free po yung PFOX. And then kahit yung application na gagamitin mamaya sa experiments with Sir Arvin, free po yung mga applications na ipapresent namin.
Alright po. And I think we have a last question here about the calibration. So may clarification lang po dito. Can we also use it to calculate error percentage rin as part of the experiment?
Maybe Sir Nel, yung calibration na ni-refer yung kanina, sir.
Yeah, it's really kung gusto mo yung sa calibration, okay, magagamit mo siya to make mas exact measurement. Pero yung in terms of yung analysis ng data mo, siguro you would need another software to look into your data. For example, pwede mong i-gather yung data and then you can plot the data. But yung nakukuha mo sa PFOX kasi yung mga live na mga graphs, for example. Pero if you want to really analyze, pwede mong gamitin ibang software like basically yung mga spreadsheets and then ipa-plot mo yung graphs mo. So, yung mga teachers can really parang gagawa sila ng activity na designed for the students, no? Hindi lang siya purely PFOX. Pwede mong samahan siya ng activities para siya yung buo yung yung experiment mo. Okay? So siguro in the future will be featuring some of those, 'di ba, ma'am? Na kung meron pa tayong mga susunod, we'll feature some of those na paano yung complete package noong experiment. Kasama na yung mga analysis po.
Yes. Okay.
Thank you very much po dun sa mga questions. Very useful po yung mga questions ninyo. And may mga questions pa yata, Ma'am Ella.
There's a question here. Is there a particular Android version with which the PFOX can be used, and how do we confirm the sensors available in our phone? I think yung sensors available in our phone, tama ba, nasa search naman yan? Kunwari,
Yes.
research
Correct.
that internet.
Kung Ma'am Ella, yung and then si Sir Mark, yung sinasabi ko kanina na sometimes hindi kumpleto yung sensor. So makikita nyo lang dun sa application nyo, pag kinlik nyo, nakalagay sensor not available. So for example, kapag may ibang phone na walang gyroscope, and then nakalagay sensor not available.
All right. So, ma'am, there's a question here. Are there available video tutorials for the other experiments? So, itong Pendulum experiment is just one of the experiments that we can perform using PhilFox.
Yes, thank you, Ma'am Rolina and Janus. So, marami pong mga video tutorials from YouTube and also dun sa PhilFox website. Nandoon yung may mga sample teacher's guide or activity sheets and video that you can use as inspiration po para i-design yung inyong mga laboratory experiments. So katulad po ng sinabi ni Sir Nel kanina, maganda po na mag-explore din tayo on our own on how we design our experiment. And then we can use this application as basically sensor para to guide us and to help us gather data. Thank you po, maraming salamat. Ang gaganda ng mga questions ni na Ma'am and Sir.
Yes, and somebody from the Zoom chat box confirmed na it will appear if available po yung sensor.
Yes, thank you, Ma'am Jeannie.
Alright po. We have a question. One of our participants from YouTube sent this question. So can we facilitate this experiment, especially in remote areas where the students don't have access to smartphones?
Very good question. Thank you for that question. Actually, for this particular experiment here, yung role talaga ng application ng PhilFox is to measure the frequency. Okay, so kung walang mobile phone yung student, then pwede naman na medyo mano-mano stopwatch. And then maybe you can count the oscillation 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you measure the time, and then you divide it by 10 to calculate for the period. So hindi lang po tayo makakakuha ng gyroscope data, yung oscillation niya, kasi wala tayong application. But for example, kung walang mobile phone yung bata or hindi natin ma-download yung PhilFox, then we can also do this experiment remotely. So yung mga materials very accessible lang po naman. So we can also perform this kung medyo limited yung resources po ng students. So thank you very much. Very, very good question po.
All right. Thank you, Ma'am Cheska. All right. So I think we have answered all the questions, Ma'am Cheska and Sir Nel. Okay, so thank you, Sir Nel and Ma'am Cheska, for preparing this experiment and for entertaining the questions. And I hope that the participants learned a lot from the open forum, right? So that has been a very engaging question and answer portion, right? So that's only the first experiment and we have another one. So without further ado, let us now flash and let's now watch this video on optics experiment prepared by Sir Arvin Husi and Dr. Rhea Mero.
Welcome to the second part of this workshop. Here, we will show you how to use your phone to do experiments with light. Particularly, we will demonstrate the inverse square law for light intensity, reflectance, transmittance, and absorbance. There are several smartphone applications you can use to perform experiments involving light intensity. But in this part, we are going to use the application called Physics Toolbox. According to the creator of Physics Toolbox, it allows you to turn your mobile device into a research tool. We will first demonstrate the inverse square law experiment. Light carries energy as it moves through space. This transport of energy is characterized by its intensity, which is defined as the power delivered by light per unit area. This quantity is known to obey the inverse square law, shown in this relation. The objectives of the experiment are measure the light intensity of a light source using a smartphone and Physics Toolbox application, and verify the inverse square law for light intensity. The materials we are going to use are meter stick or ruler, flashlight or any light source. You can also use the built-in flashlight in your phones, and a smartphone where you install the Physics Toolbox application. Arrange the materials according to the diagram of the setup, and then vary the distance between your phones and the light source. You can move your phone, or you can move the light source. Physics Toolbox will automatically record the measurements as soon as you start the experiment. However, you can always manually record the measurements in a spreadsheet and use the spreadsheet to analyze your data. Next is reflectance. Light is composed of different colors, and each color has a unique frequency or wavelength. When an incident light hits a material, some colors will be reflected, some will be transmitted, and others will be absorbed. For example, plant leaves reflect green light and absorb all the other colors. This is why leaves appear green to an observer. The objectives of the experiment are: measure the light intensity of a reflected light from a surface with different colors using a smartphone and Physics Toolbox application, and determine which colors make the surface more or less reflective using the measured light intensity. The materials we are going to use are white paper, black colored paper, and art papers according to the 7 major colors of the rainbow, flashlight or any light source, and smartphone where you install the Physics Toolbox application. We will first measure the reflected light intensity from a white paper, then from the colored papers, and lastly from the black paper. Arrange the materials following the diagram of the setup, and then measure the light intensity from each paper. Physics Toolbox will automatically record the measurement as soon as you start the experiment, but you can always manually record the measurements. Lastly, we will demonstrate transmittance and absorbance. First, let's introduce Beer-Lambert's law. When light passes through a solution, some of the light will be transmitted, while some will be absorbed. This means that the transmitted light will have less intensity than the incident light. And using Beer-Lambert's law, we can calculate the absorbance of the solution. The objectives of the experiment are: measure the light intensity of light source passing through a material using a smartphone and Physics Toolbox application, and observe the transmission and absorption of light. The materials we are going to use are, for part 3.1, art paper or cardboard, a hole puncher, and for part 3.2, water in a clear bottle, sugar or juice powder. For both parts, we are going to use a flashlight or any light source, and a smartphone where you installed the Physics Toolbox application. Arrange the materials according to the diagram of the setup, and place the paper or the solution between the light source and the sensor or your smartphone. Create holes in the paper and record the intensity of the transmitted light corresponding to the number of holes, or increase the concentration of the powder solution, then record the intensity of the transmitted light corresponding to the concentration of the solution. Hope you enjoy doing the experiments.
All right, so why don't we give a virtual round of applause for Sir Arvin and Dr. Rhea for their presentation. And before we have them for the open forum, we will first be having our pop quiz again. So The rules are the same. Whoever sends the answer correctly in the chat box will be the winner. So can I see a thumbs up if you're ready? All right. Okay, so the question is, most smartphones today have front and rear cameras. When using the physics toolbox, which camera is used as the light sensor? The front, the rear, or either? Is it the front, the rear camera, or either? There are a lot of answers being sent here sa Zoom chat box. So the correct answer is either. So it depends on the phone. So you have to discover it. So nasan ba yung sensor, no, ng phone natin? Kung nasa front ba siya or nasa back. So you can use either the front cam or the rear cam. Okay, so let me see. The first person to answer correctly is Kevin Cuarta. Kevin Cuarta. So can I ask you to turn on your camera? Kevin?
Yes po, ma'am.
Hello, Kevin.
Hello po.
Introduce yourself quickly. Are you a student or a faculty member?
Hi, I'm Kevin Cuarta po. I'm a faculty of St. Peter Perona Academy Incorporated sa Hermosa, Bataan po. I'm currently teaching Science 10, no? Pero I was able to teach Science 8 to 10, also go Physics 12 and Earth Science subjects.
Wow. So thank you, Sir Kevin, and congratulations po once again. So a representative of Filipino Science Hub or PhilSihub will message you for your prize.
Thank you po.
All right. Thank you, Sir Kevin. And now we're ready for the open forum. So let's call on Sir Arvin. So I think Dr. Mero is not able to attend here with us today. So Sir Arvin.
Hello po. Good morning. Before I answer questions from the audience, so let me just clarify. So because our smartphones today have front or rear cameras, then if you try to use the front camera and the physics toolbox application is not responding, then most likely you have to use the rear camera to measure the light intensity or vice versa. So if you're using the rear camera and the physics toolbox application wasn't responding, then you should use the front camera. So the answer is either, yeah. So you just have to discover.
Thank you, Sir Arvin. So are there any questions? Any question from the participants?
There's a question here. Sorry, ma'am. There's a question here in YouTube. Okay. Live chat. So offline po bang apps na ginagamit nyo? Okay. Yes po. You can install. You can download it from the App Store or Google Play Store, and then you can use it offline afterwards.
Okay, thank you, Sir Arvin. So just a confirmation, do we need to do this experiment in a dark room?
Not necessarily, but I think the results will be better if you're doing it in a darker room. Okay?
Yes, sir. Sir, there
because
Sorry.
the light intensity coming from your light source, I think it will be much greater than the light intensity coming from the ambient light from the room. But yeah, I think if the room is darker, then you will have better results.
All right. Thank you, sir. Sir, there are questions here about the graph. So in the graph shown, why is the linear fit used?
Okay, so as you can see, wait, maybe I can show you
Yes,
the
go ahead.
screen. Let me open the worksheet. Alright, so let me share my screen.
All right.
Okay, so can you see? Okay, so this is the inverse square law. So as you can see, inverse square law states that the intensity of the light is proportional to the inverse of the square of the distance, or the intensity is inversely proportional to the square of the distance. So um, if you are using in the plot, maybe again I'll show you the the plot using my video.
All right. So while we are waiting for Sir Arvin, can I see a heart burst from our participants if you're enjoying this talk so far? Ayan, so dami nga naman talagang nating natututunan dito sa event, right? So I hope this second session will also be as interactive as the first session. So I can see a lot of questions being sent here sa chat box. So we will answer them one by one later.
Okay, so can you see now? So as you can see here, what I used in the x-axis is the square of the distance. Okay, so not the actual distance. Okay, so it means that according to the inverse square law, okay, so this is the inverse square law. Yeah. So we have that square of the distance is inversely proportional to the the intensity is inversely proportional to the square of the distance. So the relationship of intensity and the square of distance is linear, okay, and and linear but inverse. Okay, so inverse linear relationship. So as you can see here, if we plot the graph of intensity versus the square of the distance, then we have a linear relationship, and we have to use linear fit to uh, see the best fit curve, yeah, the best fit curve or the trend line.
Yes, sir. So it really depends on the axis, right, na gagamitin.
Yes, if you're using distance only, so the relationship will not be linear anymore. Okay, so you're going to have to use another fit. Okay,
Okay, sir.
so I hope that's clear.
All right. So thank you very much, Sir Arvin. The next question po, what's the difference between FreeFox and Physics Toolbox? So a lot of questions are about the apps that you used, sir. So iba to dun sa ginamit kanina. So is one app better than the other depending on the experiment?
I think it will depend on your preference. If you like the UI of the FreeFox better than the Physics Toolbox, then you should use FreeFox, and vice versa. And then I think they will just use the same sensors, okay, or for every measurement. For example, you're going to use light. Are you going to use light intensity meter or the gyroscope in both applications? Then I think they will just be using the same mechanisms, right, to access the sensors in your smartphone. So I think the only difference will be the user interface and what if you prefer the UI of the other app than the other, then you should use that app.
But they are both free, sir, right?
Yes po. However, there are some ano nga to? There are some
Sensors, sir.
some sensors that I think you have to buy or you have to pay to use it, parang ganun.
Okay, sir. So can we use our phones and the app? I think the participant is referring to the Physics Toolbox app for measuring the intensity of UV radiation. Can we use our phones and the app?
UV radiation. I think it will depend on the capability of your camera because the application will use the phone of our camera as the sensor. So if your camera can detect UV, then you will see that the application will respond to UV light. But if it's not capable of detecting UV, then it will not respond to UV light. I mean, the application will not respond to UV light. Gusto ko lang po sagutin, ma'am, itong tanong na dapat 1/square ng distance. So, kapag po ginamit nyo, sabi ko is, di ba sabi ko nga is, dito is, I just share my screen again. So as you can see here, this is the inverse relationship, the inverse square law relationship. So if you're going set the x-axis as the square of the distance, then the relationship will be inverse linear. But if you're going to set the x-axis, so let me draw, okay, the x-axis as the whole 1/r squared, then the relationship will be linear. So your plot will be like this. It's not inverse linear. Okay? So kapag po 1/r squared yung ginawa mo yung x-axis, yan, so S, so the relationship will be linear positive relationship or direct relationship. Okay? Then if you're going to use r squared as your x-axis, then the relationship will be, as you can see here, will be inversely linear. Inverse linear. And then if you're going to set the x-axis as r only, not the square, right? So I think the shape will be like this. Yeah, I mean, it's not going to be linear at all. Yeah. So ganyan po yung ano. Then if you're going to analyze your plot, then you just have to use the appropriate curve fitting method. Okay, for example, this one is not linear, then you should not use linear fitting. Okay, then if in these two plots here, you can use linear because the relationships here are both linear. Okay, so I hope that clarifies po.
Can I ask clarificatory question?
Sorry, I
Is it all right? I think the main error in this experiment is the assumption that the light source is a point source. 1/r squared relationship with the intensity only holds true if the light source is a point source. Now, the students will be confused because what obviously appears on the plot is not a straight line. It's actually a curved line. So my suggestion is, instead of assuming a 1/squared relationship, just study the actual relation. It will come out not to be 2, but it's a bit less than 2, about maybe 1.8 or 1.7. So that's my suggestion in this experiment. Don't assume the 1/r² relationship, but analyze the data as is and get the actual relation. Thank you, Arvin.
Yes po. Thank you for your suggestion, sir. So, for this this demonstration po, so we just want to see that we just want I mean, if you're doing the experiment, for example, the students, the teachers, they will demonstrate the experiment. They will demonstrate the law, the inverse square law. So it's the actual objective is just to see that as you increase the distance, as you can see, the intensity will decrease. So actually, that's in the worksheet po na we have to it's in the worksheet po. Ito kasi po is ano lang, an example ko lang po dito sa ating slide because we have to show also for them to follow the work. I mean, for them to be able to follow the steps in the worksheet po. Yan po.
Okay, baka hindi na lang tawagin na inverse square law. Like effect of distance on the intensity na lang, ganun. Para they will not be forced to really see the inverse square law.
And meron po din, naglagay din po pala ako, sir, ng measure dito na r² na 0.964, which means that the relationship is fairly linear. Parang gano'n na lang din po siguro. Pero, yes po, tama po kayo, sir. Very useful po yung inyong suggestion. And so, dapat po, yan, para nga po maging, para maging ano po talaga yung inverse square law is, sabi po ni sir, is dapat is a point source, parang later po. However, because sabi nga po ng ibang mga nag-chat dito is, some laboratories or classes don't have enough resources. So we just have to use what's available to us. So if we only have phone cameras, phone flashlights from our phones, then at least we can see the effect of the distance, okay, with the light intensity. So tama po kayo, sir. Thank you po. Suggestion.
Thank you, Sir Arvin and Sir Ivan. I think Sir Nel is raising his hand. Sir Nel, you can unmute your microphone.
Yeah, hello Ivan. Of course, yung sample activity lang yung pinakita, but you can really do a different or so many activities na pwedeng gamitin yung light source and then yung camera. And it's good na mention mo yan because really ang ibig sabihin kasi nito is you can really do this for research, no? Hindi lang dun sa canned experiment sa classroom. Dahil kung makikita mo dito, talagang kung magme-measure ka ng totoo, no? Like yung talagang makikita mo sa light source kung lumalayo siya and so on. And there are a lot of other things that you can do na yung parang research style, no? I think it's one of the good things na dapat gawin sa estudyante ngayon even in the lab. Now, we try to do experiment na hindi yung parang susunod lang tayo sa law na available kasi parang yung canned, we need to sabihin sa estudyante na there are things na you have to do research and we might not get yung totoong data and as long as we can explain bakit ganon, then it will be all right. And I think that would be a good parang basis na ma-develop or something na trait ma-develop sa students natin, no? Hindi tayo dapat parang restricted doon sa, alam na natin kasi itong mga laws na to, nandiyan na siya, pero we can really look into, parang research style.
Can I just maybe add one more thing about, kasi may experiment kayo na maganda about reflection ng different colors. Ang ano ko lang dito, kasi ang unit na ginagamit ng smartphone ay lux, LUX. So ibig sabihin yan, ang sensor na ginagamit, yung light sensor, ay very sensitive to the wavelength where the eye is most sensitive, na bandang yellow-green yata. So yung sensitivity niya sa red at saka blue, naiiba. So baka when you measure the reflection of the red and you measure the reflection of the blue na surface at saka measure ng green surface, baka magkaiba dahil yung sensitivity ng sensor na ginagamit ng smartphone ay wavelength dependent. So isa rin yung i-consider ng estudyante regarding the actual data that he or she gets. Thank you.
All right. Sir Nel?
Yeah, maganda yung suggestion ni Sir Ivan. Kasi you can really find out kung sa lux meter or if you have access to the camera information, you can take a look at yung parang characteristic wave, characteristic curve niya. So makikita mo doon sa characteristic curve, sabi nga ni Sir Ivan, no, sensitive siya doon sa green, medyo mga 555 nanometers yun eh. So ang curve niya parang parang bell curve. Ang lalabas niyan pag tiningnan mo yung lower wavelength, higher wavelength, mababa yung niya, parang tinatawag natin na yung makukuha mo intensity. So you can really calibrate that, and also parang yung data mo parang normalize mo para pwede mo nang gamitin na as if pare-pareho yung response nung different wavelengths. Of course, maganda yan kasi students can try that, no? Marami kang pwedeng i-explore na gawin para mapaganda mo yung makukuha mong measurement.
And also, I just want to add, ma'am, dun po sa worksheet, we ask the students or the experimenter to answer the question. Why is it recommended for us to wear, for example, light colored clothes during a sunny day? So and by demonstration of that, using art paper and the reflectance of those art papers, maybe they can also answer that question. So, parang ganun. So it's not actually really the yung sa reflectance na following the yung parang because it's sensitive to the light meter is sensitive to is sensitive to the yellow green na color. So parang siya, parang hindi na po magiging effective yung demonstration. So parang just to din po, magkaroon lang din po sila ng idea kung bakit nga po ba tayo nire-recommend na to wear for example to wear light colored shirts during sunny day, parang ganun po. So parang ganun po siya. So parang sana po yung mga magpe-perform experiments, so tingnan na lang po nila yung mga objectives sa work.
All right, thank you, Sir Arvin and Sir Nel. So we just have a few more questions here in our Zoom chat box. Sir, to clarify, no, free app din yung FIFOX. Yung FIFOX, sorry, Physics Toolbox.
Yes po, yes.
Okay, so free app siya. And do the students have to have a prior knowledge on how the sensors work for them to better understand the experiment?
Based from our initial parang din po kasi kami, di ba? Katulad din for demonstration, we also perform the experiments. And also, yun po, meron pong mga experts tayo dito na nagbibigay po sila ng useful suggestions, di ba, about dun sa experiment. So, however, to answer that po, yung prior knowledge, I think readily, you can actually perform the experiments without prior knowledge. Okay? And also kapag din po kapag din po pumunta kayo dun sa sa mismong website ng Physics Toolbox, I will chat here. Ay, wala. Ay, wala. Hindi ko makita kung nasa. Ayan. So, meron din po silang mga demonstrations dun and tutorials. So, you can actually, before, if you want to have prior knowledge na din nga po, so you can actually check their website and tutorials there. They also provide different worksheets and different sample experiments dito po sa website nila. So parang kanina po may question, di ba? Na is there an experiment or lab activity instruction readily available together with the PHIFOX app? So sagutin ko po siya dito sa Physics Toolbox naman So if you follow this if you go to their website, so they will actually provide some activities din po and lab activity instructions din po for simple experiments using the application. And are there available video tutorials for other experiments? So yes po, dito sa website po, you can also see dito po sa nila, sa kanilang website. So ayun po yung sagot po dun sa prior knowledge. So I think ang sagot po diyan is without prior knowledge, you can readily use the application to perform the experiment. I mean, just by following the lab activity guides provided for example, in the worksheet na given to us by PhilSihub, or itong galing po sa website. So ayun po. But if you want to have prior knowledge na rin nga po, so yan po. Just visit the tutorials here in the Physics Toolbox website.
Yeah, Arvin, there are also many parang sample na activities that you can find on YouTube, no?
Yes po.
Maganda siya
Yes.
explore.
Opo. Yes
Ang
po.
dami-dami
In YouTube also.
Yes. Okay, thank you, Sir Arvin and Sir Nel. I think we don't have any more questions to answer. So that was indeed a fruitful discussion with our participants. And again, we really hope that you enjoyed and you learned a lot from this event. Again, thank you, Sir Arvin and Sir Nel. And that concludes our DIY physics experiments webinar. But before we end, I would like to remind everyone to fill out the evaluation form so you can receive the certificates. And on behalf of the organizing committee, we would like to appreciate and thank you for your time and for your effort in attending this event. So I would like to call on Sir Jeffrey of PhilSihub for some announcements. Sir Jeff?
Hear me,
Sir Jeff?
can you hear me?
Yes, sir. Let's just wait for Sir Jeffrey for the announcements. I think while waiting for Sir Jeffrey, we can actually have first our photo op. So if you can turn on your camera, we can just have our photo op first. So we have 11 pages here. So hold your smiles, marami tayong kailangan picturean. So Sir Arvin will be the one to, oops, also wait, I have to remove spotlight. Sir Arvin,
Thank you, ma'am. Okay po. Okay, so I will count to 3. In my Zoom app window, my Zoom window, I have 8 tabs. Okay. So we will take picture 8 times.
Request na wala po munang mag-chat para hindi matakpan yung mga nasa baba. Okay. Thank you.
Yes, Ma'am Jessica, before we proceed to the photo op.
May participants na nag-a-ask po ng link for evaluation. So, mamaya na lang pa-provide po. Opo. Salamat po.
Okay po. So, let's end po. So, I will now take our picture. Okay, so for the first tab, okay, 1, 2, 3. Okay, next tab. Keep smiling po. 1, 2, 3. Ayan. Next tab, keep smiling. Okay, so 1, 2, 3. Okay. Next tab. 1, 2, 3. Next. 1, 2, 3. Next. 1, 2, 3. Next po. 1, 2, 3. And last na po dito sa aking Zoom window. Okay. 1, 2, 3. Ayan.
Alright. Ang dami natin. So, thank you, Sir Arvin. We can now hear Sir Jeff.
Ayan. Okay, I'm so sorry. I hindi wala po akong idea kung ano nangyayari, but I was getting disconnected a couple of times. Pero you guys can hear me clearly, right? Okay, so first and foremost, maraming salamat po sa pagsama ninyo sa amin dito sa Filipino Science Hub at sa event namin with the Institute of Mathematical Sciences and Physics. So, gaya nga po na sinabi ni Professor Editha Jose, simula pa lamang po ito ng ating programa ngayong buwan ng Oktubre para po sa series of physics webinar. So last week po we had Professor Alan Alinea talking about astrophysics. Today naman po we have our physics ed group. And I think next week meron pa rin po tayong sessions. Okay, but before we end this session po, gusto ko lang pong mag-promote ng a couple of projects at PhilSihub and coming events. Could you guys see my screen? Ella, can you see my screen? All right. So, since marami pong mga bago dito na participants, so by the way, I'm Jeffrey Bunkin and I'm the founder of Filipino Science Hub. So, Filipino Science Hub is a nonprofit organization that focuses on coming up with capacity building programs to help elevate the quality of STEM education in the country. And majority of our projects right now are focused on STEM teacher development. So gusto ko lang pong i-promote sa inyo, we do have this STEM pedagogical training kit that was put together by 3 organizations. So with the Foundation for the Upgrading of the Standard of Education, Filipino Science Hub, and education leaders from Philippine Normal University. So what we did po dito sa training kit na to was we came up with 4 training courses on STEM pedagogy. So underpinnings, how to create modules, how to deliver lectures and virtual lectures. Very important, STEM teaching assessment strategies. And then we balance this with training courses that were developed by Filipino scientists from different parts of the world. So meron po tayo ditong training courses on focusing on the importance of practical and innovative STEM teaching strategies. some best practices when it comes to designing laboratory experiments and virtual laboratories. And then meron din tayo ditong crash course on the fundamentals of research. So that's one thing po when it comes to teacher training development. But then meron din po kaming program when it comes to improving yung competencies ng ating mga estudyante. So I would just like to share, to spend like a minute on this. So I don't know if you're familiar po with PISA. So PISA is the program for the for international student assessment. So this is actually the biggest standard assessment program in which about 80 countries participate. And unfortunately, in 2018, the Philippines ranked the lowest. So yung 15-year-old Filipino students po, pinakamababa po tayo dito sa assessment na to. There's a number of findings po dito. So unang-una, doon sa 6 na proficiency levels when it comes to reading comprehension, science, and mathematics, Filipinos ranked the lowest. Only 1 in every 5 Filipino students passed this assessment. So talaga pong napaka-depressing ng performance. And then at the same time, yung pong proficiency level ng mga students hanggang awareness or familiarity lang. So they don't know how to apply the concepts, they don't know how to synthesize out of those concepts and use their knowledge from their classes in being creative or in practicing creativity. So kulang po sila sa higher order thinking skills. Nandun lang po sa lower order thinking skills ang ating mga Filipino students who took this assessment. So as an intervention to this, Filipino Science Hub has recently launched like a modules program that is focused on assessment. So meron po tayo ditong mga supplemental instructional materials. We're starting to cover science in grades 3 and 7. Situational and experimental or exploratory po yung approach natin dito kaparehas nung dineliver ng ating physics team ngayon. So, but ang focus po nitong project na to is essentially to provide teachers with assessment tools that would help you inculcate not only lower order thinking skills but also higher order thinking skills. So, ang plano po natin dito is hopefully kung makumpleto natin yung coverage ng buong curriculum ng grades 3 to 10, students sa Philippines when it comes to science and math, hopefully po makatulong to makapag-improve ng performance ng mga Pilipino estudyante when it comes to assessments like PISA. So ang goal po natin, yung assessment tools natin ay magamit natin to encourage students to develop a strong passion for the sciences and math. So yun po yung ating plan. And then ultimately, mas marami pa tayong ma-produce na mga Filipino scientists and mathematicians in the process. Ayan. Okay. Lastly, so there's this fundraising program that I'm promoting right now. So this is Filipino Science Hub's project to support its research university. So research university is one of its major program. It strengthen yung foundation po, knowledge ng ating Filipino students and educators when it comes to the practice of scientific research. So this is our third fundraising project for this year, and ang focus po nito is on how to decode patents for research. So through this series of lectures, so October 16 po, so Sunday next week, and then the 30th, we will be teaching you some very relevant concepts in intellectual property. So ano ba yung intellectual property? Specifically, laging takot yung mga students to read patents because naguguluhan ako, hindi namin alam kung paano ba mag-extract ng information dyan. So we will also teach you the basic structures of a patent, writing and reading patent claims. So tuturuan ko kayo ng strategy yan. I have about 12 years of worth of experience reading and writing patents. And then most importantly, how can you read patents effectively and extract research information from it? Kasi, yan, ang napapansin din namin sa Pilipinas, karamihan ng sources natin ng information for research ay academic papers, no? Kasi merong tawag dito, intimidation sa patent. Like, ay, mahirap yan kasi may mga decoy information. Paano ba namin iintindihan? So, you will learn the art of unpacking information from patents from someone who has more than a decade of experience of reading and writing up patents. So, yun. yun yung mga events po natin ngayon. But then, hindi muna ako matatapos dyan, Ella. Hindi ko muna ipapasa sa'yo kasi I have one more thing to share with all of you. So, we really appreciate yung partnership natin with the Institute of Mathematical Sciences and Physics from UP Los Baños. So, dyan po kami nanggaling. Majority of the leadership team members of Filipino Science have graduated from UPLB, and kami po ay produkto rin ng mga physics teachers natin sa UPLB. So at this point, we would also like to share this certificate of appreciation to our facilitators and speakers for today. I will have to make some corrections on the date, but allow me to award this certificate of appreciation to Ana Pamela De Jesus from the Institute of Mathematical Sciences and Physics, University of the Philippines, Los Baños, for delivering the webinar DIY Physics Experiments, organized by the Filipino Science Hub and held via Zoom and YouTube Live on the 8th of October 2002, signed by yours truly and JP Onya, Chief Technology Officer of Filipino Science Hub. We would also like to award this certificate of appreciation to Mr. Arvin Lester Husi. I'm hoping I'm not butchering your name, from the Institute of Mathematical Sciences and Physics, University of the Philippines, Los Baños, for delivering the webinar DIY Physics Experiments, organized by the Filipino Science Hub, held via Zoom and YouTube Live on the 8th of October 2002. We would also like to present the same certificate of appreciation to Ma'am Francesca Isabel de Vera of IMSP-UPLB, Professor Ranzivel Rojas Villanueva. Maraming salamat po for your generosity when it comes to putting the team together and creating these materials, and most importantly, sharing your expertise with our Filipino Science Hub community. And then we would also like to present the certificate of appreciation to Professor Nelio Altovero. So yun, maraming salamat po. We hope that this is actually not not the last collaboration. So we had a total of about 405 or 410 live participants today. Maraming salamat po sa inyong pag-spend ng inyong Sabado ng umaga, patanghali na dyan sa Pilipinas. Ayan. Ella?
Alright. Sir Jeff,
Yes.
we would like to ask for the evaluation form link.
Yes, yan po. Isasend ko na po yan sa inyo ngayon, not just sa Zoom, but also sa ating YouTube. Ayan po. So, wait. I think it got sent to a specific. Ayan po. Nakikita nyo na po ba yung
Yes.
Google form link?
Sure.
All right. So we'll give them siguro po a couple of minutes to click on it para ma-access nila. And then if ever po meron sa inyo na makamiss nung link, we will also be posting it on the Filipino Science Hub Facebook page and also sa amin pong website, so www.philsihub.com. Ayan.
Thank you, Sir Jeff, and we hope to see you on our future events. So thank you, everyone, and have a good day sa atin dito sa Pilipinas.
Ayan.
Good evening, Sir Jeff, sa inyo.
Ayan. Sabi na po dito, about 10:30 in the evening. So maraming salamat po sa pagsama ninyo muli sa amin. Yes, Zoom. Yeah.
Yes po. About yung link po, it says dynamic link not found po actually.
Oh, really?
Yes po.
Okay, so let me...
Okay sa akin.
Okay po ba sa inyo?
Yes, okay sa akin.
Yeah,
Okay naman
yes,
po sa
okay
akin.
sa akin.
Lang po.
Yes, we can access it.
Okay, check mo lang ulit.
Very good. Yeah, okay. I'll check it again.
All right.
Thank you, everyone.
Ingat po kayo. Maraming
Thank you so
much. Team Physics Ed.
Thank you, Jeff. Dr. Jeff. Medyo unstable yung ating internet.
Opo. Ayun. So we'll see you all.
Unstable yung internet ngayon, kahit sa akin.
Kahit po dito sa amin. So we'll see you again. We'll see you again next week. Next Saturday.
Yes.
Maraming salamat po. Ingat po kayong lahat. Thank you, everyone. Enjoy your weekend.
Ang dami natin.
Yeah. Bye.
They are waiting for more.
Opo, waiting for more. Parami ng parami. Opo.
Mukhang
Ayan.
nabitin sila sa ating DIY experiments.
Ng kasunod na session po, for sure. Ayan. Maraming salamat po. Take care, everyone.
Thank you po. Marami pong salamat.
Thank you, Physics
Bye.
Division.
Thank you.
Salamat po.
Bye.
Thank you po. Thank you.
Maraming salamat.